Hi everyone. Now we are going to study about question number 46. That is about motion of center of mass. What is the velocity? What is the acceleration? What is the shift in the position of center of mass? And how to calculate all those things. So in this way, the very first thing is what we have to understand is what is the velocity and acceleration of center of mass. As we have seen already, the position of center of mass is m1 r1 bar plus m2 r2 bar, so on mn rn bar whole divided by total mass of the system m1 plus m2 plus so on mn. Then if you differentiate both sides, then you will get the rate of change in position, nothing but velocity of center of mass, that is m1 v1 bar plus m2 v2 bar, so on mn vn bar whole divided by m1 plus m2 plus so on mn. Similarly, acceleration of center of mass is m1 a1 bar plus m2 a2 bar, so on mn an bar whole divided by m1 plus m2 plus so on mn. So here the main thing what you have to take care is direction of velocities of the individual particles or acceleration direction. So when you consider the proper direction, you will get the proper vector representation. If they gave already in the vector representation, then no problem. But if they did not give, then according to the given data, you have to take the velocities or accelerations in terms of vector representation. So then only you will get the proper answer. So this is the formula for velocity and acceleration of the center of mass. Now, the next thing is, what is the shift in the position of center of mass? See here, usually they'll ask question based on this, like when there is a disk or sphere of mass m, radius r. Now from this, when you remove a small portion of radius small r, and the removed portion mass m1 and the remaining if you consider m2, then it is just like what happens is the original center of mass is this one. Let's take C, and this is C1, the center of mass of the removed portion, and the center of mass of remaining portion will shift to another point C2. So on a line, when you consider C1, when you consider C2, when you consider C, C is actual center of mass of M1 and M2, nothing but total mass. Now C1 is center of mass of removed portion and C2 is center of mass of remaining portion. Now here this is called shift in the position. X is called shift in the position. Now this is the distance of center of mass of removed portion from the original one. This if you take as x1, this you take it as x2. So this x2 is shift. Then here the mass m1 is there. Here the mass m2 is there. Then m1 x1 equal to m2 x2. Now the question is how to calculate m1 m2. So how do we calculate m1 m2 is, see m1 is mass for pi r square. M is mass for pi r square in case of disk, or m1 is mass of 4 by 3 pi r cube and capital M is mass of 4 by 3 pi r cube. This is in case of sphere we will consider. So that if you cross multiply you will get small m1 in terms of capital M. And capital M2, how to find is, capital M2 is nothing but small m2 is nothing but capital M minus M1. Because M1 plus M2 is nothing but total mass. So this way they can ask question based on the shift in the position of center of mass. Now, how to deal with person moving on smooth plank? When you consider this is a surface and one plank is placed, the length of the plank is L and a person is standing here. Now, when the person of mass M moving on the plank M, by the time he reached the other edge, so he reached the other edge, the plank will go back by some distance. Let's take this distance as x. So even though he traveled a distance L, his displacement with respect to ground will become only L minus x. So here, as there is no external force on the system, velocity of center of mass is 0. Therefore, shift in the position of center of mass is 0. That's why here m delta x1 plus capital M delta x2 should be 0. That means m into L minus x plus capital M into minus x equal to 0. Why minus x? Because the plank is going backward by x. That's why minus. And the person went forward by a distance L minus x with respect to ground. So that here you will get the relation m into L minus x equal to mx. So same case they can also ask with the what we call it as wedge, a block sliding down on a wedge, triangular wedge which is placed on a smooth surface. By the time the block came down, the wedge will move back by some distance. In that case also same formula we can use it. But here the thing what you have to remember is if F external is 0, then d VCM by dt is 0 implies VCM is 0 or VCM is constant. As initially velocity of center of mass 0, that's why it remains at rest. If already velocity of center of mass is having some value, some constant value, then as there is no external force, it continue to move with the same velocity. So based on that fact, they may ask the question. Now, two bodies. Let's see the examples based on whatever we have discussed. So the very first one, two bodies of masses 1 kg and 2 kg are moving with velocities. So V1 bar is 2 I cap plus 3 j cap and V2 bar equal to 3 I cap plus 4 j cap respectively. Then velocity of center of mass of the system. Now velocity of center of mass of the system is m1 v1 bar plus m2 v2 bar by m1 plus m2. Now m1 is 1 kg, v1 is 2i plus 3j. Directly they have given in vector form so that the question became easy. 3i plus 4j whole divided by m1 plus m2 1 plus 2. So now how do you add the vectors? Item to item. So 2 plus 6, 8 I cap, 3 plus 8, 11 j cap. So 8 I cap plus 11 j cap by 3. So that way, so depending on the simple formula they use to give the question. Now the next question. A 10 kg boy standing in a 40 kg boat on a water is 20 meters from the shore. Let's take this is the shore. Just consider. Now, one boat is there and the boat is at a distance. If he moves 8 meters on the boat towards the shore, now he is on the boat at a distance 20 meter from the shore. Now he moved 8 meters on the boat towards the shore. Then how far is he from the shore now? See, if he went 8 meter, actually 20 minus 8, 12. But by the time, during that time, the boat also moves backward. Like, see, this is the position. Now, the boat may move like this. Means the boat went back by some distance x. Now the person reached here. Now the person moved by a distance of 8 minus x. Actually went 8 forward and x backward, equal to capital M into x. Then person mass is 10 and 8 minus x equal to, what is the mass of boat? 40. So 40x. So 0, 0 cancel. So 8 equal to, if it goes that side, 5x. Then x equal to 8 by 5. That means 1.6. 1.6. That means it went back 1.3 meter. So how much distance he came forward then? Let's say this is y. Now the y distance will become, he came 8 forward and 1.6 back. So that the resultant is how much? 6.4. Now initially he was at a distance 20 meter. Now he is at a distance 20 minus 6.4, nothing but 13.6 meters. Now he is at a distance 13.6 meter from the shore. So as I explained one example, based on that, this question is given. Now, two particles of masses move towards each other under their mutual force of attraction. No other force acts on them. So the very first thing what you can conclude is F external is 0. If F external is 0, velocity of center of mass is either 0 or it remains constant. But here, initially, the both are at rest and they started moving towards each other due to their mutual attraction. That means velocity of center of mass 0. Therefore, at every instant, velocity of center of mass remains 0 only, as there is no external force acting on the system. So mutual interaction is just internal force, not external force. Now one more question. Two particles of masses 100 gram and 300 gram have at a given time velocity. At a time they have velocities respectively, then velocity of center of mass of the system. Again same simple question, VCM equal to, now M1 V1 bar plus M2 V2 bar by M1 plus M2. So here only thing what you have to take care is just calculation. M1 given directly, M2 given, V1 given, V2 given. So you have to add I terms, you have to add J terms, you have to add K terms properly. And no need to convert grams into kg because they will get cancelled, numerator and denominator. And no need to convert centimeter also because they are asking the answer also in terms of centimeter per second only. Just substitute and do it. Now, one last and final question. So as I said, there is a question they can ask based on the shift in the position of center of mass. A uniform sphere has radius r. A sphere of diameter r is cut from its edge as shown. Then the distance of center of mass of remaining portion from the center of mass of the original sphere is. See, a uniform sphere has radius r. A sphere of diameter r is cut from its edge as shown. Then the distance of center of mass of remaining portion from the center of mass of the original sphere. So it is nothing but shift in the position they are asking. Now if you look at the diagram properly, see here. This is the actual radius and the removed one is like this. That means the small r half of the original radius. Now our formula is m1 x1 equal to m2 x2, where this is x1, that is center of mass of distance of center of mass of removed portion from the original center of mass. And this is the shift x2. Now how do you find m1, m2? As it is here, I said that m1 is the mass for 4 by 3 pi r cube and capital M is the mass for total 4 by 3 pi r cube. If you cross multiply m1 is m r cube by capital R cube, where small r is r by 2, if you substitute you will get m by 8. When m1 is m by 8, m2 will become m minus m by 8, nothing but 7m by 8. Now m1, m2 we got in terms of capital M, and x1 is this one. From the diagram, x1 is capital R minus r by 2. See, this is r by 2 and this is r and this is r by 2. So this is r by 2, this total is r. So what is x1 will become? R minus r by 2, nothing but r by 2. Now you got m1, x1, m2. So what you can find? X2. So this way from the given data you can find x1, and from the formulas of what is the mass of m1 for means for how much volume the m1 is mass and what is the total volume. If you cross multiply it, then you will get m1, m2 values. Then you can find x2. So this is the common procedure in case of sphere or in case of disk. So similar kind of questions I have given, like I said, wedge case here I have given. So similar questions I have given as assignment. So please try to solve the questions. So thank you all of you. We will continue in the next session with the next question. Thank you.